Good day, guys. All right, so we are at the last subchapter for chapter one, all right? And we'll be talking about significant figures. Significant figures generally just talks about the number. So, say you have 5 Kelvin, right? Some value that you measured, temperature that you measured, and it says 5 Kelvin, and Kelvin is a unit that we've covered before, and the value is 5. The magnitude is 5. So how significant is this value? How many significant figures are there? In order for you to determine it, you will be doing it based on several rules. So here are the rules. So there are quite a number of rules, 8 rules to be exact. Feel free to pause the video and then try to figure out, read it through, try to understand, try to give yourself examples, and then see if those examples match the examples I'm about to give. All right. So pause the video if you need to or if you want to. Okay. All right. So let's look at the first one. All non-zero numbers are significant. Okay, so say you have the value 2400. Okay, these are non-zero values, so I have a significant figure here, I have a significant figure here. The other two are zeros. They are zeros, so they are not significant. Therefore, for this value we have two significant figures. Okay, all right, so let's look at the second one. Zeros between two non-zero digits are significant. Again, we had 2400 just now, but now we add a 1. Now these zeros are in between non-zero digits. So are they significant? Yes, they are. So now we have 5 significant figures. So I have 5 significant figures. Okay, next one. Leading zeros are not significant. So say I have the value of 25, right? Here I have 2 significant figures. Okay, say I add another 0 in the front, 025, or maybe 0025, or maybe 000025. Now, because these are leading zeros, they're in front and they're not in between any non-zero digits, there's no numbers, there are no non-zero numbers in front, they are all 2 significant figures. Okay, they are not significant. Okay, so let's look at the next one. Trailing zeros to the right of the decimal, right, are significant. Okay, trailing zeros to the right of the decimal are significant. So say you have 0.0057, right? Now, are these, trailing means behind, so are these zeros behind the decimal? Yes, it is. See, the decimal is here and the zeros are here, right? Okay, so we have 4 decimal places. So that means we have 4 significant figures. All right, next one. Trailing zeros in a whole number with the decimal. So with the decimal, all right, means that if I have 58, 580, and then the decimal, this 0 is very significant. So then we have 3 significant figures. 3 significant figures. But you have to make sure that the decimal is there, because trailing zeros in a whole number with no decimal shown are not significant. So again, I'll take the same example. So 580 with a decimal, this is 3 significant figures, whereas 580 with no decimal is 2 significant figures. Okay, that's the difference. Next one. Exact numbers have an infinite number of significant figures. So exact numbers meaning, so for example, if I write 2, I can also write 2.0, I can also write 2.00, I can also write 2.00000, and so on and so forth. So they have an infinite number of significant figures. Okay, and the last one, for a number in scientific notation, so n times 10 to the power of x. So for example, 7.04 times 10 to the power of 7, all digits comprising of n, so this is n, are significant by the first 6 rules. So the first 6 rules, 10 and x, so 10 and x, this one, are not significant. So these two are not significant. So here we will have 3 significant figures. All right. So that is all, and that's how you determine how many significant figures there are. All right. So here are the 8 rules again, to sum it up. And I'll see you in the next video. Thank you guys.